Chapter 7, it's 7.1 here. We are solving systems of two equations. This should be super easy. You guys did this last year. I don't know if we've really done it this year at all, but just a kind of a brief reminder of how to do some of these. The first method we're using is substitution. Okay, so what we want to do here is we want to isolate a variable. Typically you want to pick a variable that doesn't have a number in front, so we're going to choose to isolate this negative y. So we want to get that y by itself. So we subtract 2x to both sides. Okay, now we still have to deal with the negative in front, so we have to divide everything by -1. So y equals -10 plus 2x. Now, if you want to switch that to 2x minus 10, it doesn't matter which way you go with that, just make sure the signs are good. Now, the substitution comes, now that I know what y is 2x minus 10, I can plug that in to y in the second equation. So my new second equation is 3x plus 2 times 2x minus 10 equals 1. So it's the same exact equation, except for y we have 2x minus 10. Distribute your 2. So 3x plus 4x minus 20 equals 1. Combine like terms. Okay, add your 20. Divide by 7, so x equals 3. Okay. Now, you got to find y. Well, over here, y equals 2x minus 10. So plug 3 in for x. So y equals -4. Okay. So again, that's just a quick review of how to do substitution. You guys should already know how to do this. Alright, a word problem. Okay, it says find the dimensions of a rectangular garden that has perimeter 100 feet and area 300 feet squared. Well, first of all, perimeter is 2x plus 2y. Okay, so if we let x be the length and y, that's the printer. I'm in the math office. Okay, so 2x plus 2y is the perimeter. Well, the perimeter is 100. Okay. Now, area of a rectangle is length times width. So, length times width equals 300. Okay. Now, we're going to do substitution. Okay, it says to do substitution. So, what we're going to do is we're going to do something with the first equation. I'm going to divide everything by 2. Whoops. Somebody's copying a book. Okay, so divide everything by 2 in the first equation, you get x plus y equals 50. Alright, now, you can get whatever you want by itself. If you want to get y by itself, subtract x over. Okay, so there's your new y. So now take 50 minus x. Whoops. Take 50 minus x and put it in right there. So you've got x. Can't even write an x. X times 50 minus x equals 300. Okay, so we distribute 50x minus x squared equals 300. Move everything over, so it's x squared minus 50x plus 300. Now I'm going to tell you right now you can't factor that, and I'm out of room. So what you want to do is use quadratic formula. Okay, and I'll be interested to know what answers you got tomorrow because I'll be asking. Elimination. We want to eliminate a variable. In other words, we want to add down the columns and be able to eliminate a variable. Okay, we can't do that right now because if we add down the columns, neither variable cancels. So what we have to do is we have to change one or both equations to get the same numbers in front of x that are also opposites. So I'm going to choose to eliminate x. So what I'm going to do is I'm going to multiply the first equation by 3 and the second equation by 2. Now the one thing you have to remember, you have to distribute to all the terms. So I have 6x plus 9y equals 15. That's the first equation. And then I have negative 6x plus 10y equals 42. Now if I add down the columns, the x's cancel. I get 19y equals 57, so y equals 3. Now take 3 and plug it back into one of the original equations. I'll choose the first one. So 2x plus 3 times 3 equals 5. So 2x plus 9 equals 5. 2x equals negative 4. X equals negative 2. Okay? So just a quick review on elimination. Alright, last one. Table 7.1 here shows the personal consumption expenditures in billions of dollars for dentists and health insurance in the United States for several years. So here's your table. Here's your problem. Find linear regression equations for the U.S. personal consumption expenditures for dentists and health insurance in Table 7.1. Superimpose their graphs on a scatter plot of the data. So you have to do lin-reg. Okay? How do you do lin-reg? Okay? So what you're going to do is you're going to let x equals 0 be the year 2000. Whoops. So year 1 would be 2001. Okay? So, for the dentist, use L1 and L3 in your calculator. For health, use L1 and L3. Okay? So, find your regression lines. So, find, actually, what do they want? The equations, yeah. So, find the equations. Okay, and you're going to use lin-reg. Okay. Okay. Now, whoops, why do I keep doing that? Then graph the two lines. Okay. Or if you want to do the well, actually, you probably do the scatter plots. Well, the scatter plots you'll already have because you have the points. So graph the lines. Okay. The lines should fall right on top of the scatter plot. Okay. Now, boy, I keep hitting the wrong thing. Now, Part B, it says use the models in Part A to estimate when the U.S. personal consumption expenditures for dentists was the same as that for health insurance and the corresponding amount. Find the point of intersection. So when I check your notes tomorrow, I will be expecting you to have all this information for me because you'll have to use your calculator to figure it out. I've told you what to do, so now you just have to go ahead and do it. Okay? So that does it for 7.1.